As you may already know, cardiovascular disease still remains the leading cause of death worldwide. However, drug development in this area lags behind other specialties, mainly due to the high cost and the complexity of cardiovascular clinical trials. Additionally, there's only a limited number of drugs available that targets the myocardial function directly. Therefore, there's an unmet need for drug repurposing if a drug can directly improve cardiac function in a time and cost-effective way. In the next 10 minutes, I would like to show you the potential of MAO inhibitors in improving the mentioned cardiac parameters in animals of chronic heart failure. Currently, there is no clinical data that validates our preclinical findings. Therefore, we would like to suggest the designing of a propensity score mesh study. My name is Sevda, and I'm currently a first-year MD PhD student under the Department of Pharmacology and Pharmacotherapy. And together with my research team, my vision is to enhance cardioprotective strategies by investigating how existing treatments can be further optimized to improve cardiometabolic health. My aim is to do this by researching the cardiometabolic effects of MAO inhibitors. My first project will focus on the cardiac outcomes. To understand the mechanism of action of MAO inhibitors, I would like to first introduce the action of MAO enzymes. MAO enzymes are responsible for breaking down monoamines such as serotonin and dopamine. Therefore, with the use of MAO inhibitors, we prevent the breakdown, leading to improved mood and motor control, which is used in treating neuropsychiatric conditions, used in major depressive disorder and Parkinson's disease. Now, although MAO inhibitors have a well-established role in treating neuropsychiatric conditions, its cardiometabolic effects remains underexplored. Studies regarding this area show that increased MAO activity correlates with aging and heart failure with an exacerbation of oxidative stress. MAO inhibitors, which are known drugs with a well-tolerable risk profile, have shown to reduce adiposity and therefore improve cardiovascular health. Therefore, we aim to prove this cardiac benefit with supporting preclinical evidence. This leads us to our first clinical questions. Do MAO inhibitors have cardiovascular benefits in animal models? To address this, we'll be using a PICO framework, with our population being animal models of chronic heart failure receiving MAO inhibitors as treatment and compared to the control group receiving vehicle treatment such as saline. Our primary outcome measures will be key cardiac function parameters such as fractional shortening and ejection fraction, and our secondary outcome measures will be cardiac and inflammatory biomarkers, blood pressure, and other echocardiographic structures. We hypothesize that preclinical evidence do suggest cardiac improvement with the use of MAO inhibitors. To answer this clinical question, I have used three main domains for my search key, separated into intervention, disease, and species, and finally, these were searched against three different databases. On the right-hand side, you can see our flowchart selection. We have started with around 5,000 articles, and we have narrowed to 13 eligible full text. Next, I would like to present the results of our outcomes. All data will be presented as mean differences. Our first outcome measure will be ejection fraction, which is a key indicator of systolic function, and it reflects the proportion of blood pumped from the ventricle in relative to the end diastolic volume. It's expressed as a percentage. However, currently there is no guideline or standardized reference ranges that would help us interpret the ejection fraction results of experimental animals. As you can see, we have created two separate forest plots for each species, rats and mice, because species have different baseline ejection fraction values to begin with. And finally, the data was subgrouped based on the chronic heart failure models. The heterogeneity was 40% in rats and 74% in mice. And for rats, we have 3 studies with 3 different populations. For mice, we have 3 studies with 4 different populations. Such a heterogeneity is considered high. However, this was expected given that we have different heart failure models, different time of outcome assessments, and varying dosages of MAO inhibitors. The mean difference was 20.68 in rats and 11.92 in mice. This indicates that despite we have a heterogeneous setting, both species that have administered MAO inhibitors have shown an increased ejection fraction upon MAO inhibitor use compared to those who have not used MAO inhibitors. Our next outcome measure will be fractional shortening, which also reflects the contractility status of the heart. However, unlike ejection fraction, which is a volumetric-based parameter, fractional shortening reflects the intrinsic contractility of the cardiomyocytes, and it's measured by calculating the change between the end diastolic and the end systolic diameter. It's also expressed in percentage, and so a higher fractional shortening would mean better contractility. We have the same subgroups and the same species as previously mentioned. This time we have 3 studies with 3 different populations for rats and 2 studies with 3 different populations for mice. The heterogeneity was 23% in rats and 83% in mice. Again, this is considered a high heterogeneity, however, this was expected given the diversity of our protocols included. The mean difference was 9.69 in rats and 17.52 in mice, which together with aligns with our previous findings that also in fractional shortening, species who have administered MAO inhibitors upon chronic heart failure, they have an increased measure of fractional shortening compared to those who have not. However, both ejection fraction and fractional shortening has shown only statistical significance in rats. Our final outcome measure will be brain natriuretic peptide, which is a key biomarker in heart failure used in diagnosis and prognosis, and it often reflects the severity of heart failure. Here, unfortunately, we had enough studies to only pull together results for rats. And the BNP levels presented here reflects the expression levels of BNP in the ventricles. Here we have 2 studies with 3 different populations with a heterogeneity of 91%, and the mean difference was negative 59.16, which indicates that rats who have administered MAO inhibitors upon chronic heart failure have a decreased level of BNP levels, although this was not statistically significant. Moving on, I would like to conclude that MAO inhibitors did show potential in improving the mentioned cardiac parameters irrespective of the animal type or the heart failure model. Therefore, we would like to suggest the designing of a propensity score match study that would compare heart failure patients that are already taking MAO inhibitors to those who are not. Currently, I'm working on the results section of my manuscript, and we are aiming to submit in the Journal of Cardiovascular Research. My second topic will be about the metabolic outcomes. So studies have shown that MAO inhibitors plays a key role in blocking key components that contribute to the development of metabolic syndrome. For example, in diet-induced obesity models, MAO inhibitors have shown to reduce fat content and adiposity, and also increase insulin sensitivity and decrease blood glucose levels. In a cholesterol-enriched diet model, MAO inhibitors have shown to decrease triglyceride and cholesterol levels. Therefore, we aim to prove these metabolic benefits with supporting preclinical evidence. Our second clinical question is, do MAO inhibitors have metabolic benefits in animal models? And our population will be animal models of metabolic disorders receiving MAO inhibitors as treatment compared to the vehicle treatments such as saline. This time, our outcome measures will be specific to the metabolic disorders that we would like to investigate, and we hypothesize that preclinical evidence do suggest metabolic improvement with the use of MAO inhibitors, and by confirming this, we could suggest a potential use of MAO inhibitors as therapeutic agents for metabolic disease prevention and management. The search key for this project will be similar to the previous one. However, this time domain 2 for the disease will be specific to the metabolic disorders that we would like to investigate. Finally, I'm aiming to submit these 2 projects within 1 year, and I would like to end this quote by a quote from Seneca, that luck is when preparation meets opportunity. Thank you for your kind attention.
Congratulations on your presentation. So I have a question regarding in your first project, you mentioned that MAO inhibitor could be used for heart failure. Did you, based on your study, based on your understanding of the articles, have you seen any difference between the standard care or the MAO inhibitor? Are there any evidence that these might be superior to the standard of care?
You mean in the clinical?
Yes.
The problem is we initially started to, we planned on investigating the clinical effects of MAO inhibitors. However, the problem was that in this population, in these articles who have examined the effects of MAO inhibitors, they usually excluded patients with cardiovascular comorbidities to begin with. So it's really hard to come with a conclusion and say that MAO inhibitors have improved cardiac function if they don't have such a population to begin with. That's the reason that we did a meta on preclinical studies.
Thank you.
Hello, congrats on your presentation. My question would be, what do you think, which would be next for the, I'm asking the question for the first project. What do you think, what could be the next step towards, for clinical trials or anything? What could be the next step?
Yeah, our implication was that to design a propensity score match study or a prospective observational study that would compare patients who have heart failure, and on top of their standard of care, they're also taking MAO inhibitors, and compared to those who are not taking MAO inhibitors.
Thank you.
Yeah.
Congratulations on the presentation. My question would be, why did you choose to present the results with the rats and mice? Is it that you think their cardiovascular system is most likely to humans, or is just that there were articles in that species?
Honestly, I'm happy to even have rats and species being able to pull them together because there was so limited data. These preclinical studies, usually they tend to target novelty, so they tend to select species or heart failure models that hasn't been done before. So it was really challenging to find the same species with like heart failure models and also administering MAO inhibitors. So this was the available data that I have now. Of course, I have those species with pigs and rabbits, but they were not enough to be included in the meta-analysis, but they will be included in the systematic review part.
But if you could choose one out of those that you've been listed at the search key, which one would you choose? Which animal?
Pigs, of course, because they're more likely to reflect human physiology. And actually, our results were pretty nice. Unfortunately, we had only one study with pigs. Yeah.
Thank you.
Okay, if there is no more question, I would like to ask one more. You said there are only a few or very limited number of studies. Would you suggest more animal studies in this aspect, or should we go forward and test humans?
That's a very difficult question. We could have more preclinical studies with large animals, with pigs or like dogs, which could better reflect the human physiology, and also chronic heart failure models that maybe have a higher or longer follow-up times compared to what I have now. However, I think because MAO inhibitors are already in the market and we have information about its side effect profiles, I think it would be enough to test different dosages as different points of the trials. Yeah.
Thank you very much. If there is no more question, sorry, very short. Sorry.
So very, very short question. Chronic heart failure is a very complicated syndrome almost, and ejection fraction is not necessarily the thing that we need to improve in order to fix chronic heart failure. Why did you choose ejection fraction? Because positive inotropy, increasing oxygen demand of the heart, that's not necessarily something we want to increase very quickly.
The thing about our definition of chronic heart failure is that in preclinical models, there is no exact definition for chronic heart failure or acute heart failure. So this definition is strictly based on the follow-up times of the heart failure models to begin with. So we selected those outcome measures that can be easily measured both in the clinics and also in preclinical settings to increase the translational value of our studies. And we also picked those outcome measures that are according to the heart failure definition of the ESC, heart failure, which often includes ejection fraction and BNP levels. Yeah.
Okay, thank you very much.
Thank you.
We should move forward.